Good morning, everyone. Uh, so today we are trying to uh, take up this discussion on project work. The idea is that I have been getting some calls. I vividly remember that I have got a call from Rohit. I've got a call from Reena yesterday. Mohit has also called me, and Shilpa has also written a mail to me. So I have been getting these calls, and they were all asking that what should be done and what should not be done. So I thought that why not I take a class around this. So what I would advise you to do is that if you have any specific query, I am in constant touch with the chat window. You can please write your query into the chat window. By the time I will tell you, and we will discuss that what potentially we can do. Uh, what I have understood out of your queries. So please feel free to write your queries in the chat box. I will take up queries one by one. This is a query analysis task that we are doing today. So feel free to write your queries. Last time when we have discussed this, I think I have told you till the reliability thing. I have told you how to uh, how to measure the reliability of your data using SPSS. This is what we have done. We have also talked about uh, we have also talked about how we can also talk about how we can kind of uh, do the further tests. So what I have done there is I have shown you some points which you can follow, and those points were if I can show you now, these points were important for all of us to understand. These were the points. So first of all, we were talking of to start from point number one. Point number one was to point number one was to point number one was to test your reliability. This is what we were trying to do. Point number two was uh, test reliability for each construct that you are having. Number three is uh, when you have done this, it reliability should be greater than 0.6, right? This is what also we have looked at that day. Once you have reached to this stage, when you have actually got your reliability done, when you have got your data tested, now it depends upon what your objectives are. From here we can discuss further what we can do. Now other day I was telling you that many of you have the objectives like uh, what is the impact of certain factor onto something else. Now just to give you an example, uh, like if suppose you are trying to test the impact of say work life balance onto the satisfaction of employees, hypothetically I am saying, you might have some factors which are representing the work life balance, and then you have a question which is measuring the satisfaction. So the satisfaction can also be having more than one question. It might be having two questions, it might be having three questions. So that way you look at your satisfaction thing also. Now you will run the impact. So the impact would be factors of say work life balance. I am writing it like this: on to satisfaction. So this is suppose you are trying to do. Now you might have different type of uh, objectives with you. Depending upon whatever your objectives are, you can kind of check uh, what are your objectives and what type of impact you are going to test. So having done that, you would need in such scenarios you would for this you would need regression, right? Now then, one more question which I think we should be looking at is this: from where to get factors? from where to get factors. The students who are in touch with me, I've been telling them that you might be having more than one question to measure anything. Now, for example, Pranab has been in constant touch with me, and I was telling him, he has shown me his questionnaire. In his questionnaire, there are many questions which are trying to measure the forwarding intention of WhatsApp messages. So he's having, say, more than 10 questions, more than 15 questions. Now we need to look at it like this, that all these 15 questions are actually measuring the WhatsApp messages forwarding intentions. So now we have two options with us. Either take all the questions, or what are the options? And option number one is either take all the questions one by one. So if you have 16 questions, so you are going to have 16 analysis, which is not a thing that we should do. Or we can reduce it, or we can reduce the questions, right? Reduce the questions. So when we are talking reducing the questions, we can talk of factor analysis. So factor analysis will do what? It might reduce. So suppose in case of Pranab, we can reduce, say he has 20 questions, 20 questions can be reduced into, say, 5 factors. And then these 5 factors would be used as factors, and they might be tested against anything that you are looking at looking impact at. Now, for example, in Pranab's case, I have asked him to add a question, and that question was that I usually forward WhatsApp messages. So this question is measuring that actually someone is forwarding the messages. So when someone is forwarding the messages, what factors can impact this thing, and hence whatever the factors that he has, he can actually then kind of look at this type of regression thing. So in detail, what is factor and what is regression, I have already told you that I have video factor analysis. You can actually go and test it out. Now with this, let me take up the questions. Some students have come up with certain questions. So the first question has come from Pranab. He says, what is the minimum number of responses we need for reliability test? Okay, Pranab, to this question, the minimum number of responses, actually in statistics, we say that any sample which is less than 30 is called as a small sample. Any sample which is larger than 30 is called as a large sample, right? Now, uh, so in your case, when you're asking what is the minimum number of minimum number of responses, you look at it like this. As a rule of thumb, we say that whatever the number of questions you have, you should have, say, 5 times of those questions if you are applying any of the multivariate techniques. Now, for example, if factor analysis is to be applied, you should have around 5 times of the questions. In your case, I think if you have at least 100 questions, that would do, because you are not going to generalize the results of it onto a very large population. So for your answer, the state for your question, the state answer is that it can be somewhere around 100. So if you have 100 responses, you can very well check the reliability, right? I hope you know how to measure the reliability. If Pranab, it is still something that you want to ask on this, you can please type in. Now I'm going to Shilpa. Shilpa is saying, is validity required to check even after reliability? You need not to check validity, Shilpa, in this case, because validity testing is much more a complex thing. And on top of it, as you specifically, as you are using a scale, which is a standard scale, so you need not to go with the validity of the data. So you need not to worry about it, right? So you just check the Cronbach alpha, which is the reliability, and I think that would be sufficient for your case. Okay, then we have Sachin. He says, sir, how can we check reliability when questions are on different scale? Now, this is a questionnaire formulation problem, Sachin. Uh, First of all, you actually need to look at how you have taken up your questions, how many constructs you have in your project. Now, for example, I have already told you that if you have, say, 3 things in your project, and for 3 things you need to measure reliability separately, and on all these 3 things you need to have, suppose in first thing you have 4 questions, these 4 questions should be on the same scale. If your questions are not on same scale, then it is a problem. You would not be in a position to measure the reliability in a good fashion, which is expected to be measured. So Sachin, if you have your questions on different scales of the same concept, then it is a real problem. Better it is if you have not collected the data, you better make all those questions on the same scale. So this is how we can look at it. ओके सो अजय आस्किंग सर लिकर्ट स्केल के साथ ऑर्डिनल नॉमिनल स्केल कर सकते हैं एसपीएसएस में. यू कैन डू ऑल द फोर स्केल्स अजय, देयर इज नॉट एन इशू विद इट, बट द ओनली थिंग इज that when you are talking of taking ordinal scale and nominal scale, the type of analytical tools you require, they would be absolutely different. Because you have done the factor in your business statistics and research method class, because you would have done ANOVA and T. These three things are very easily applicable onto the Likert and ratio scale, which is called as a continuous scale. So I would not advise you to go to the ordinal and nominal scale, at least when you're analyzing the data, because all the parametric test requires the data to be measured on metric scale, and metric scale is continuous scale. Continuous scale is interval or ratio, right? So this is how we kind of look at it. So Ajay was asking what is WLB. Ajay, I was just giving this example. WLB is work-life balance. This is a hypothetical example I gave. Does it lead to satisfaction or not? Right. So this is something that we are looking at it. Now, since it's factor and regression. So in between, Shilpa says, I have objective for identifying dimensions and satisfaction. So do I need to go for factor analysis also, or regression itself? Shilpa, in your case, definitely you have to do factor analysis. There is no question on this. You have to do factor analysis, right? Uh, Subsequent to this question, let me tell each one of you, if you have questions for one construct which are more than one, suppose many of you, almost all of you would have more than one question measuring the same thing. In that case, you need to reduce those questions, and to reduce it, you need factor analysis, right? That is how we would require factor analysis to be done. Once you have reached onto the factor analysis, then you can look at regression analysis. So first factor, then regression analysis, right? So let me show you how does it work. The sequence is uh, sequence is number one, reliability, then factor analysis, then regression, then ANOVA or T, depending upon your thing. Anushri is asking what to do if the KMO value is less than 0.7. Anushri, you can still accept it if you have it around 0.6. Even if it is 0.6, you can accept it. So it is not an issue. You can still go ahead with 6. If I am to tell you, even there are papers accepted in journals where the KMO value was even less than that also, but there are a lot of explanations to this, which I think is not the scope of this discussion. Pranav says, I have 12 factors and 2 questions for each, that is 24 items in total. Should I test reliability of 12 factors separately, or should I categorize those 12 factors further? Pranav, in your case, you should do what? You should take all the 24 questions as measuring one scale, and that is the intention of forwarding, right? All your 24 items are measuring one thing, and that one thing is the forwarding intention of WhatsApp messages. So which means you will treat all these 24 questions as to be one thing. And when you are measuring reliability, all these 24 things are to be taken into reliability thing. Once you are done with this, then you run factor, and now you will come to the factors. Then you say you've got 5 factors, 6 factors, or 12 factors. The factors would come later on, right? Okay, I will show you how to run factor also. अजय इज आस्किंग सर कंज्यूमर बिहेवियर आइडेंटिफाई करने के लिए वेटेड एवरेज मीन टेस्ट लगा सकते हैं या नहीं. Ajay, consumer behavior is a very vast term because as we have already done consumer behavior, so consumer behavior might include perception, personality, self, attitude, learning, culture, preference groups, whatnot. So it is a very vast term. Now, in what context you are saying that can I have this weighted average mean? I need more kind of explanation from you to know what exactly you are trying to ask. But better would it be that you do not get into this weighted average mean and all those things. You simply do this sequence that we are looking at, reliability factor, regression, and ANOVA, right? I will show you how to do this. रोहित इज आस्किंग सर, मैं सभी टेस्ट कर चुका हूँ, रिलायबिलिटी फैक्टर एनालिसिस, रिग्रेशन, टी एंड एनोवा, बट कौन सी आउटपुट को डाटा एनालिसिस में यूज करना है? वंडरफुल क्वेश्चन रोहित. It's a very, very good question. SPSS gives you bulk of output tables. Which one to use is something that is very important to see. So very quickly, let me tell you, if you have used reliability, Cronbach alpha you would have got, you report the Cronbach alpha. Factor analysis, when you have run, you report KMO and Bartlett's test, that's it. Then you need not to report anything. You just then make a table which shows that these many questions has made one factor, and then you report the name of those factors, and that I think would be sufficient, right? In regression, you report the ANOVA value, that the regression model is significant, and the beta value, unstandardized beta value, which you will use to make equations, right? I will show you that also. So that is, I think, sufficient in regression. Similarly, in T and ANOVA, you just show us that whether the results are significant or not, so which means the significance column, and the mean value of the category. Suppose if you are applying T, you have two categories, suppose male and female, so you show us male and female significance or not, and then you say the mean for male and mean for female. Similarly for ANOVA. I will try to show this to you also. Thank you, Roy, for asking this question. Anushri says, but sir, it is coming less than zero point 0.5, so do I need to formulate again my project work? Anushri, if it is coming less than zero point 0.5, you need not to formulate again your project work. What you can do is you need to get rid of some questions which are bringing the reliability of your data down, right? This is what you need to do. There are some questions in your data which are bringing the reliability of your data down, so you need to be getting rid of those questions. What you can do to do that, you look at the correlations table, and the questions which are coming on to SPSS thing. Okay, so wonderful. Okay, Sachin is asking, sir, if there aren't questions about satisfaction, then any problem can occur or not in factor analysis. It is a very, very, context specific question, Sachin, in the sense that the questions, which questions are there, they do not influence the factor analysis. Factor analysis is done for actually one construct. So if you are, so say a while ago I was giving example for this Pranab, that if he has 24 questions for intention, all 24 questions are taken into factor analysis. If satisfaction is the thing, satisfaction would not come in this, as is the reliability for construct wise. Say same way the factor is for construct wise. Now I am on to this Excel, I am on to this SPSS sheet. If I can show this to you, this is how you will do it. I'm assuming that you have measured the reliability. So for measuring reliability, what you can do is you go to analyze, you go to scale, a very quick thing, you go to reliability analysis, and then suppose this 1 2 3 4 5 6 7, these questions are measuring your construct. You take them in and you check onto statistics, and you just check onto the scale, and you say continue, and you press OK. When you do that, you get this table, and this is what you get from back alpha 0.805, right? 0.805, so which is a very good reliability. When Rohit was asking what to report, Rohit, you need to report this. The reliability is 0.805, right? Cronbach alpha value is 0.805. Now coming on to the factor analysis, something which is troubling you the most. To run factor analysis, you go to analyze, you go to dimension reduction. From dimension reduction come to factor. So again, analyze, dimension reduction, factor. This will give you this window, right? So this window, then you need to take all those questions that you have taken in while measuring the reliability. Now suppose all these questions I would take, these all are measuring one thing, I would take all of them together. So what my idea here is, when Pranav was saying that I have 24 questions. All 24 questions are measuring the same thing. So you need to look at all those 24 questions as to be one thing only, and all those are to be analyzed for factor analysis, because you need to know how many factors would be there into these questions. Okay, so I am doing this. Now go to descriptive. In descriptive, you check KMO and Bartlett's test. Say continue. I am little fast, but since this is getting recorded, so you can watch it at your own ease. Then I go to extraction. In extraction, you select the default thing only, which is principal component analysis, the method, and eigenvalue. Let it be this only, and you just say continue. You don't need to change anything on this. In rotation, when you click, you select Varimax. Varimax means variance maximization, right? So you can look at the full length video factor analysis and you will come to know what it is. And you say continue. And then you say OK. Saying OK would give you this thing, right? So any other questions? Let me see first. Okay, oh, fantastic. So here this KMO is coming 0.820. For some people it might be less, as Anushri is saying that my KMO is less than 0.5. So in that case, Anushri, you should do this: analyze, scale, reliability analysis, and these questions, go to statistics and look at these correlations. So this inter-item correlations. When you will check this, when you will say continue, you will get the correlation table. So I am pressing OK, and this OK is giving me this correlation table. You see it is written inter-item correlation matrix, right? So this inter-item correlation matrix is actually speaking about the correlation which this item has with all rest of the items. So items here are questions. You check for this correlation for any statement. When this correlation is less than 0.3, the maximum correlation is less than 0.3, you consider deleting that statement, because that statement would be bringing the reliability down. So what I am telling you is this: you take this copy. So what I am doing this, I am copying it, I am taking into my Excel, I am pasting it, right? I have pasted that thing, and now you delete one. There is reason why you delete one, because when you are trying to measure the maximum correlation, it will always be 1, because 1 is the maximum value here. So we don't want our formula to return this thing. So you say equal to max, and you select this entire thing, and you close the parenthesis, and you send this formula down. When you will do this, you will now get this thing is maximum correlation, right? Maximum correlation. So this maximum correlation is 0.538 for this statement, for this question. It is 0.5 for this question. So if this value is less than 0.3 for any of the question, you start considering this question for deletion. So suppose if this would have been 0.298, I would have deleted this question. So you do not take this question as part of your analysis. You delete this, and then without this you run the reliability, right? So this is a very quick thing of what you can do when you are having the low reliability. Okay, now I'm coming back to factor. So you report this 0.820. It should be greater than 0.6. Then this table is of no use to you. You need not to report it anywhere. Then you straight away come to this table, which is total variance explained. It is very important to report how much variance is explained by your factors. Now this table tells you how many factors have been extracted by your data as a result of factor analysis. Now since this calculation, this extraction calculation has stopped after factor 3, you see after 3 you see this table is empty. So which means it has stopped calculating the extraction, and there is reason for this. The reason is that after factor number 3, the eigenvalue has gone less than 1, right? So which means you look at this for 3, the eigenvalue was 1.073, but in 4th it has gone less than 1. And why it is so? Because if you go to analyze, if you go to data reduction, if you go to factor, in extraction you have extracted on a condition that its eigenvalue should be greater than 1, right? So when it is not 1, it has stopped extracting. So this is just to show you why it has stopped at this. Now you need to report how much variance is explained. In this case, 53.140 variance is explained. right? So 53.140 would mean that almost half of the variation in this model is explained. So this further means that though you have 15 questions, you can have 24 questions. So in case of Pranav, you had 24 questions. These 24 questions or these 15 questions are now reduced into three factors, and these three factors are uh, 1, 2, and 3, and these are explaining 53% of the variance. Ideally, this variance should be at least 60%, because when it is 60%, that means still you are losing 40% of the information, which is a huge amount. But in social sciences, if it is 60%, we still take it, right? So it should be 60% and should be reported. Now then you should come to the rotated component matrix. In rotated component matrix, you should see that which which item is loading on which factor. So this is factor number 1, factor number 2, and factor number 3. So this question is having maximum value for which factor? So it is 0.65341 minus 0.1042 0.213 for factor number 3. So this is maximum for factor number 1. So this question goes to factor number 1. So likewise, you look at each of these statements and you see that for which statement the value is maximum. So for this factor, the statements would be number 1, number 2, number 3, number 4, number 5, number 6. And for one factor, you have the 6 statements. Now what is happening? This factor number 1 is representing this 6 statements. So that is why this is called as data reduction tool. It has reduced 6 statements into one factor, which is factor number 1, right? So you need to note down somewhere. Suppose I am writing down onto my word. So here what I will do is I might be writing down that f1, which is factor number 1, is made up of uh, question number 1, question number 2, question number 3, question number 4. You write it down like this, right? So that you remember. Similarly, you look at factor number 2. Similarly, you look at factor number 3. In this case, we have 3 factors, right? So that is how you can look at it. Once you have done this, now you know that your 15 statements has been reduced into 3 factors. Now you will take these 3 factors ahead. So what we were doing, reliability of checked, the factor analysis, here the result is 3 factors, right? The result is 3 factors. So now you are not taking ahead all the 24 questions or all the 15 questions here. You will only take ahead 3 factors. Now when you are running regression analysis, in regression you have dependent variable and independent variable. So dependent variable, you take what you are checking effect on. Suppose you are checking effect on satisfaction, so it will be here. Satisfaction will be a dependent variable. So spellings are wrong, you can take it off. Satisfaction. If you are independent variables, what you will take? The factors. Here 3 factors have come up, right? So these you will take factors, right? So now this is how you will do it. This is how you will come onto the regression. Now if you will see, you need these 3 factors to be taken into the further analysis. So which means you should have the data on these 3 factors. But by now we do not have data on these 3 factors. If I can show you, I am going back to my SPSS file. I am getting rid of my output. I am going back to my SPSS sheet. Now here on SPSS sheet, if I can show you my data view, I have only questions. Question number 1, question number 2, question number 3, question number 4, question number 5, question number 6, whatever. But I do not have any data on factors, right? Here I have calculated factors, so you do not look at these factors. I will show you how to calculate this, right? But actually when you are filling your data, you have the data on these questions only. So for example, on question number 1, you have the first respondent saying strongly agree. So actually if I can show you, I will go to view and I will uncheck value labels. So now you have 1 2 1 2 1 2 1 2. So this is what you actually have. You have for question number 1, the first respondent saying 1. For question number 2, the first respondent saying 1. For question number 3, the first respondent saying 2. So 2 might be disagree, right? This is and you can check view and you can check value labels and you can know what is 1, what is 2, what is 3, what is 4, right? So this is what you have. So now you need the factor scores. This is what we call as factor scores. To calculate factor scores, this is important. Do not overlook it. You have to go to transform. This is the transform here, right? You go to transform, you come to compute variable, right? So again, let me tell you, this is my word file. You need to have these three factors here, which is highlighted. To get the score of these factors, you have to go to SPSS file, go to transform, and go to compute variable, right? This is where you will come. When you will come to compute variable, you click onto this and you will come with a window, and this window would look like this, right? In this, suppose target variable is f1, right? This is what your factor name is. Now I am going back to my word file where I have written what is factor number one. Factor number one was question number 1, 2, 3, and 4, hypothetically. So I know that this, so take gross mean of question number 1, question number 2, question number 3, and question number 4 for factor number 1. So this is what I will do. So factor number 1 is made up of 1, 2, 3, and 4, hypothetically I am saying. So you come to this window, it says numeric expression. So f1, which is factor number 1, is equal to what? Is equal to, come to this function group here, right? You can see function group. You click onto anything and you come to statistical. So you press S, and you press S 3 times, it will come to the statistical function. And within this function group, because this is function group, within this group you have so many other functions. So you select mean from here, right? And it will tell you what will it do. Mean is returns the arithmetic mean of its arguments that have valid non-missing values. This is the explanation of it. So what I need to do, I need to take gross mean of question number 1, 2, 3, and 4 for factor number 1. So this is what I am doing here. I am coming to my this SPSS thing. I am selecting mean. You look at this little up arrow. You select mean and you press it and it will go up. You see the mean has come up now, right? This is where you just concentrate on my cursor. Now it is having some question marks. So you have 4 questions in this factor. So you delete these question marks and you take questions. So the question number 1 I am selecting, press this arrow and this will come here, right? So the question number 1 has come. You see the Q1 is written here. You say comma, question number 2 take in, comma, question number 3 take in, and then the 4th question in. So what I am doing here is f1, this is my target variable, this is what I want to compute, is equal to the mean of question number 1, 2, 3, and 4. And why I have done this is because in my word file it says question number 1, 2, 3, and 4. The mean of these 4 things is factor number 1. So this is what I have done. Factor number 1, mean of question number 1, 2, 3, and 4. And I say OK. The moment you will do this, it is saying me that change existing variable, because I already had a variable with f1, so I cannot do this. Let me give a different name to it. Suppose this is test factor. Do not give a space to this. It will not accept the space also. So I will press OK, and it will give me a new factor. You see. So in output, if you will come into the data view, you see this is my data view. Go to the last. I have a test factor which has come. Now its score is for respondent number 1. This score is 1.50. For respondent number 2, this score is 2.25. For respondent number 3, this score is 1.75. Basically, for respondent number 1, whatever he has responded to question number 1, 2, 3, and 4, you have taken the mean of this, and that mean is 1.50. Right? So this is how you get the factors. So you had 3 factors. So as I have shown you, calculate the score of factors. You might have 2 factors, someone might have 3 factors, someone might have 4 factors. So depending upon that, you can do this. Now I'm assuming you have the 3 factors, or whatever number of factors, you have the score of those factors with you. So once you have this, then you will run regression. Then we come on to the regression analysis, right? So this regression analysis, to do that, what we can do is you go back to your SPSS file, you come to analyze, then you come to regression. Regression is there. In regression, you select linear, right? In regression, you select linear. You click onto this, and you will come up with a window, and this window would look like this. Whatever is your dependent variable, you place it here. So suppose I'm taking this question as my dependent variable, so I'm taking this in. Suppose my independent variables are now what? Remember, in my Word file, I have factors number 1, 2, and 3. I have shown here this independent variables will be these three factors. So I am going to take the factors as my independent variables. So I am coming down. In last you have these factors. So I am selecting factor number 1, factor number 2, factor number 3 as my independent variables. So these have come here. Rest you left as it is. Don't change anything. Come to statistics just to show you what you need to test. Model fit, that is enough for you. Plots, you just take the histogram and the normal probability plot. That is sufficient for you. You need not to save anything. Options, you have everything perfect here, and you just say OK. Right? When you will say OK, you will come up with this window. Right? Let me enhance it. This window will tell you that you have a r square value. Rohit was asking what to report. You need to report r square here. R square tells you how much change in your dependent variable, which is this question. In your case, it can be satisfaction, it can be anything else. How much change or how much influence these independent variables, which is factor number 1, 2, and 3, have exerted on your dependent variable, which can be satisfaction or whatever. So if this thing is 0.290, r square is 0.290 here. So if this is 0.290, so that means almost 30% of the change in your dependent variable is explained by these three independent variables taken together. So which means that 30%, up to 30% of the satisfaction, if satisfaction is your dependent variable, is influenced by the three independent variables. And what are these independent variables? These are factors. So I was taking this example from the Pernod thing. He is doing this forwarding intentions, 24 questions. These 24 questions are taken into factor analysis. Factor analysis would give him factors. Suppose three factors have come up. Now these three factors are representing all the forwarding intentions, and then he take these three factors as independent variables into the regression thing. His dependent variable would be, I usually forward WhatsApp messages. So the model which is now being built up is that when you are forwarding a message, what is it that influences it the most? So you need to see from these three factors which one of these factors are contributing to the forwarding intention of WhatsApp messages. So to that, the r square suppose is 0.29, so which means 30% of forwarding intention is explained by these three factors which we are running here in regression analysis. This thing which is significant, this should be less than 0.05 if the regression model is to be sufficient enough, or is to be significant enough. Now then you come on to a very important table, which is this table, coefficient table. So to explain this, I am copying it and I will take it to Excel so that I can show you how do you report this. So I'm coming on to a new sheet. I am zooming it up and I'm pasting it. So this is the sheet that has come up now. You see it has unstandardized coefficients and it has standardized coefficients also. So let me do this. Let me not make it so big so that it is going away. So let me wrap the text so that everything is visible. Okay, fantastic. Now, so this is what we are setting up with now. This unstandardized coefficient is very much important to you. What it is telling you, dependent variable is shown here. So if I can merge these cells, so the dependent variable is clearly visible. So dependent variable here is, I like this advertising very much. So in your case will be, I usually forward WhatsApp messages, and these are your three factors, right? F1, F2, and F3, and these are the constant, and these are the these are not constant, these are beta values, right? And these are your there is some problem in this. Let me come back. So the significance is this 0.418.233, 0.418.233. So there is some, let me paste it as a picture. Copy, Let me paste this as a picture. This is how I think it would make more sense, right? So this is how it is. Pasted it. Yes, now it has come, right? So what I'm trying to do is I'm doing nothing, but I'm pasting it as a picture so that we can see as it is whatever is the thing here. So it is also creating problem in this mode. Forget it. We will take it from there only, right? So now look at this. Look at this SPSS output. SPSS output is this. You need to look at this unstandardized coefficients, which is zero point 0.06 for F1, 0.62 for F2, 0.25 for F3. These are most important things for us. Now we will make a regression equation. Very important thing also to look at the significance thing. So this significance, which is of ANOVA, is telling you whether your regression model overall is significant or not. This significance tells about the individual factors, whether they are significantly contributing to the model or not, right? This is how we kind of look at it. So you see, for F1 the significance value is 0.233, which is not less, which is higher than 0.05, so which means it is not contributing significantly. So F1 is out of the picture, so F1 is not contributing well. For F2 and F3 this is less than 0.05, so which means out of F1, F2 and F3, F2 and F3 are contributing to the regression model. So which is, when you are asking this question, I like this advertising very much. For this, only F2 and F3 are contributing, F1 is not contributing because it is not significant. So in this case, you will come here in your, so the regression equation will be, what will this be? I like this advertising. So this is question, this is dependent variable, I am writing it as dv. The constant is, you see here, the constant is 0.246, 0.246 plus, since this is not significant, I am not writing it, 0.620 and this and F2, right, plus 0.257 and F3, right? This is how we will look at it, right? So this is your regression equation. Now this regression equation tells you that F2 and F3 are positively contributing to your dependent variable. So in WhatsApp forwarding intention, F1 and F2 are contributing positively. How much they are contributing? So each unit change in F2, the dV value would change by 0.620, right? For each unit change in F3, the dV value will change by 0.257, and hence this is the model that we are talking about. Now we will come to know that out of three factors of say purchase intention, two factors are contributing to the WhatsApp forwarding intention. And then you now know that you need not to be considerate about factor number 1, factor number 2 and 3 are important to you. And now what we will do is, here you have come ANOVA and t-test. ANOVA and t-test run only for those factors which have come significant in, so let me drag it here, significant in regression analysis. So why I'm writing it so is because you see the factor number 1 at all is not contributing to the dependent variable. So why do we study it? We need not to study it because it is not contributing. So you just should go with those factors which are significant in regression analysis. So here you have only factor number 2 and factor number 3 are significant, and you run ANOVA and T for F2 and F3 only, right? This is how we look at this. One very important thing which is now left, which I must tell you, what are these F2 and F3? You don't know what are these. How will you calculate the F1, F2 and F3 is, suppose F2 is made up of question number 5, question number 6 and question number 7, right? Similarly, F3 is made up of, suppose, question number 8, question number 9 and question number 10, right? Suppose this is how they are made up of. You will give a name to factor number 2. This is called as profiling of factors. So which means naming of factors is called as profiling of factors. Profiling of factors, right? So how will you give name? Look at the question number 5 and question number 6 and question number 7. Where will you find these questions? Go to SPSS and get rid of your output. Come to your data view, go to variable view, question number 5, 6 and 7. Question number 5 is this is my question. So if I can broad it, it says I will be pleased after using the advertised product. Question number 1. Question number 2 is I feel the advertised product would excite me. Question number next is the advertised product would make me calm. So you now give one name which represents all three. This is something that is called as the profiling of factors. So suppose the first question says if one is feeling pleased after using advertised product. Second question is that it excites also the user. Third is that it make him calm also. So you might call it as positive effect of advertising because all the three things are positive. So maybe you can give this name to this factor, right? So this is how you give the names to this factor. Look at the significant factors and then run the ANOVA and T only for the significant factors. So I hope that you know what is ANOVA, you know what is t-test. If you have any issues in ANOVA and t-test, recently and very recently I have done live streaming for ANOVA and t-test also. You can go to those videos, they are right there on my channel, and you can look at the ANOVA and t-test thing, and that is how I think you can uh, you can look at all those things, right? And that perhaps would save the things for you. So this is I think I should tell you. Now let me look at your questions, and we can take these questions one by one, and then you can let me know if you have any issues, further issues, we can still discuss it. So I have addressed this thing when Pranav says I have 12 factors and 2 questions. I have addressed this, so I think this is done. Second, Ajay, consumer behavior, this is also done. Rohit says, sir, मैंने सभी टेस्ट कर चुका हूँ. What to report? I have already spoken on this. This is wonderful. Then Anushri says, but sir, it is coming less than 0.5. I have spoken this also. This is wonderful. Sachin says I have spoken on that also. Uh, Ajay says if there are more than 15 questions for analysis, then we can take all questions or 6 or 7 questions. If all these 7 questions fall only for Likert scale only. Yes, Ajay, that you can do. If you have only say 7 questions which are onto the same scale, you better take only those questions. Otherwise, the things would not be easy for you to do. Why they will not be easy for you to do? Because you will not be able to apply certain tools and techniques. So when you are not able to apply those tools and techniques, then you know that it is going to create problem to you. Okay, so Pranav is asking how to do data cleaning, identifying outliers and inadmissible responses. Pranav, data cleaning is a very, very complex exercise. There are tons of things that you can do to clean the data, but to give you a very quick response to your question, you can go to SPSS and you can check the box plots. And forget box plots, that is even a little more complex. You can simply look at the descriptives of your questions. So descriptive of the questions would mean you can look at its mean, its median, its mode, its skewness, its curtices, right? So the skewness and curtices should not be greater than 1 or 2. If they are greater than 1 and 2, then that means there is some problem with the data. For each item, you can check these things. You can look at, if you are using 5-point Likert scale, you can also look at the maximum minimum value while you are doing the descriptives. Many times it so happens that your 5 might become 55. That would also be highlighted. If you want to go further away, you can do the box plots also, right? So box plot would tell you that which questions are outliers, right? So I think that is something that can be done to it. So if you know how to run box plots, you can let me know. Otherwise, I think it is good to go ahead with this. Yes, Ajay, you can run factor analysis in 6 to 7 questions also. There is no issue on this. You can run. Factor analysis doesn't stop you on how many questions you can run it, as long as all those questions are measuring one thing only, right? So if they are measuring one thing, you can actually do that, right? So this is for Ajay. Any other question on this? Today we have discussed at length how to run factor, how to run regression, and how to kind of explain these things also. So this is what we have kind of run it. So anything else on that we can discuss? Any specific question? I can take those questions. Yes, one more thing. I'm now recalling. Mohit was calling me, and yesterday Rina has also called me. Mohit's case is little different in the sense that Mohit is first doing a qualitative thing. He is first taking interview of 10. I don't know, Mohit, are you there? If you are there, then only it makes sense to speak on this. Mohit, if you are there, then you can put it in chat box. If you are not there, then we can there is no point in discussing this, because if you cannot listen, uh, I hope it will go unattended. So this is not what I want to do. So Mohit, if you are there, you can just ping me in the chat box, right? We can take it up. So, any questions? Because I have got call from Shilpa, Pranab, Rohit, and Jagrati also has called some time back, and Mohit was also calling some time back. So, if any one of you have any questions, please ask. I can show you how to run in SPSS. If you want to see how to run it in SPSS, that we can actually do. So, anything in specific, you can let me know. And by the time, let me also show you how to report this. Let me try to find out. Let me try to find out something, a dummy table, which is maybe of use to you, of the question that Rohit was asking, how to report and how to make tables. I'm trying to find out that thing. Uh, Give me 1 second. I'm just going through my papers, and I will show you some of my papers where I have kind of published this. Okay, right. So let me show this to you, what you can report and what you cannot report. Uh, Let me add up. So you can, by the time you can write down your this thing, you can write down your questions if there are any, and I can kind of do this. So let me. Any questions? Oh, Ajay, thank you so much. It has come from you. It means a lot. Thank you so much. I'm trying to show you something which is creating problem for me now. Okay. Uh, Let me open my PDF file. Okay, so mm, capture. This is going to be PDF file. Okay. So what I am showing now is uh, a paper of mine, which I think where I have explained in detail how do mm, where is that paper? So by the time uh, you can please write down your questions if you have any. No, this is not the case. Okay, forget this. Now let me take you to my this thing. Uh, okay, so this is the paper. I wanted to show you. I hope you can see this now. In this paper, this was published in Paradigm in Sage, that was long back, but I have used regression and I have used factor both in this paper, right? So this is how you can report your demographics. So this is a demographic thing. You see demographic profile of respondents. This is gender, male and female, and this is how I think this is an easy thing. This is a post tabulation. You can later on pause video and can spend some time on it so that you can understand it. So I paused here purposefully so that you can understand this. But what you can report in factor analysis. So see here, this is how you can report. So Rohit, when you was asking this question, I have written all 21 statements were put to factor analysis to find out dimensions. The value of KMO, measure of sample adequacy, comes out to be 0.76. And Bartlett's test was found out to be significant. So that's it. You just report that factor analysis with principal component analysis and Varimax rotation was applied. You report this, and then eigenvalue was 1. That also you can report it. It is very important to report how much variance is explained. So 57% of variance is explained. So this is what also is reported. Now this is an important table. This is the factor influence on children. I've given name to this factor, and these are the statements which has loaded on this factor, and these are factor loadings. You remember what are these factor loadings? You can make this table. This is a wonderful table. Let me show you what are these loadings by going into my SPSS and by going to my output file also. So this is my output file. If I can go to my factor thing, this is factor. Let me come down, rotated matrix, and let me make it a little big. You see, this is your this factor loading. So I like this advertising very much. It is maximum for factor number 1, so 0.653. So 653 is highest for factor number 1, so it is going to factor number 1. So you write this 0.653 here. So this is what I've written. So this 0.71 is that 0.653, right? So you write it here. And then for the second question, you write this factor loading for question number 3. So these many questions were loaded on this factor, and these are the factor loadings for these things. This you can report, right? This is factor number 1. This is factor number 2. This is factor number 3, right? So this is how you can report it, right, for factors. Coming to regression analysis, this is what you can do. I have done stepwise regression analysis in this paper, but for you, the example that I've shown, that was done using the enter method, right? The different methods, don't get confused. There are reasons where you use stepwise, where you use enter method. Just to show this to you, I'm going back to my SPSS thing. From here, I'm selecting regression. I'm clicking on regression. You see, it says method is enter method, right? If you would go to analyze, into regression, into linear, this is where the method is there. So method is enter method, right? So there are a lot of methods. So one is stepwise also. So in that paper, I've used the stepwise method. I'm cancelling it. I'm again going back to this. So this is how you can report it. This is constant. This is the significance. So these 3 factors, these are significant factors because all of them value is less than 0.05. So you use this table in your project, and using this table you make this equation which is made here, right? So very clearly written R1, which is dependent variable, which is this. 0.648 is the constant. This is significant also, so this is significant. So you are reporting this constant here. Plus, why is this plus? Because these all values are plus. These all beta values are plus. This is a plus value. This is a plus value. This is a plus value, right? 0.270, 0.276. These are all plus. So plus 0.289. 0.289 for this factor, influence on perceived quality. So this is PQ, perceived quality, right? Then 0.276. This is for societal status. So 0.276 for societal status. 0.270 for positive influence. So this is what I've depicted as P, and this is what I've written down also. So SS is influence on societal status, P is positive influence on advertising, and PQ is influence on perceived quality. So this is how you can report a regression table, and you then need to write that what was your r square. You can report it within this, and this is where I've explained this all, that what does it mean, what does it don't mean, and this is how you can kind of explain this. Okay, so then this is the discussion. So I think that with this we have looked at lot many things which may be of use to you. Again, if specific questions, please you can ask. Uh, I want to ask the question which is related. What family are checked on which scale in SPSS? Maybe I did not get your question, Ajay, here. You write, I want to ask the questions which are related with family are checked on which scale in SPSS. In SPSS, I think everything has to be on a scale. So, uh, if I'm getting your question right, so let me come to the SPSS file so that I can show you. So, in this SPSS file, you can see that that this thing, which is your which is your measure. You see everything is scale, right? Everything is scale here. So this all is scale. So everything has to be on scale. If it is on to scale, you can run all the parametric tests because this is metric data. Right? So this is how you can kind of look at this. So it has to be on this scale. So I hope if I've understood your question right, this is how we can look at it. So okay, any other question on this? The rest of this is I have shown into the word thing also to you, that you can go to my channel where the uh, where all those things are available, in the sense that the ANOVA and T, you can run the ANOVA and T also, so that way you can check all those things up, right? Okay, so final thing onto this, uh, run regression, run ANOVA and T, and then report your results, right? So this is what I wanted to show you, right? Test reliability for each construct should be greater than 0.6. Then run factor analysis. How to run factor analysis I have told you. After factor you run regression, and after regression you run T and ANOVA only for those factors which have come as significant